What is grounding? You've probably heard the term grounding in relation to genai models. Grounding in the context of AI refers to the process of ensuring that AI's responses are based on real-world knowledge and facts, rather than purely on the patterns it has learned from its training data. This is vital for maintaining the accuracy and trustworthiness of the AI's outputs. In simpler terms, it's like anchoring the AI's responses into a solid foundation of truth, ensuring that what it generates is coherent and factually correct. And grounding, of course, is essential because without it, AI systems can produce outputs that are incorrect and potentially misleading or harmful. It's especially easy to see why this would be critical in fields such as healthcare, finance, and legal services, where incorrect information can quickly lead to severe consequences. However, even for any other business who is using it to generate, say, product information to share with a customer, you're going to want that information to be factually correct, or you're going to be creating a very confused customer. Grounding techniques help to mitigate these risks by ensuring that the AI's outputs are firmly rooted in verified data and real-world knowledge. Effective grounding can involve integrating real-time data sources, employing human oversight, and using multiple models to cross-verify outputs. By combining these approaches, organizations can significantly enhance the reliability and accuracy of the AI systems, ensuring that they provide valuable and trustworthy insights. So what are the top LLM grounding challenges? Well, one of the biggest challenges with large language models is their tendency to generate plausible but incorrect or misleading information, often referred to as hallucinations. These hallucinations occur because the models generate text based on statistical patterns rather than actual factual knowledge. Another challenge is embodiment. Since LLMs are trained on text, they're very good at predicting which word follows another, but adding logic is not so easy, so linking textual representations to actual physical entities is difficult. For example, understanding the concept of a hat in the physical world versus just reading about it. Data ambiguity is another significant hurdle. Real-world data is messy and full of inconsistencies and uncertainties. Your grounding efforts must overcome these drawbacks to let your LLM reconcile ambiguities and make sense of that data that is often incomplete or contradictory. This involves cleaning and reprocessing of data to ensure it is accurate and consistent as possible before being used to train AI models. Contextual understanding is also crucial. The same input can have different meanings in different settings. An LLM must learn to interpret language within specific scenarios and adapt its responses accordingly. Contextual understanding is an ongoing challenge that requires continuous learning and adaptation to learn new data and contexts. For example, the word bank can mean a financial institution or the side of a river depending on the context. Lastly, knowledge representation poses a dilemma. It's often unclear how best to represent real-world knowledge in an LLM's architecture. Should your LLM try to mimic human cognitive abilities, or should it process information in line with its actual computational nature? This is an active area of research and is an ongoing challenge in grounding. Effective knowledge representation ensures the AI system can understand and use information in a way that's meaningful and relevant to the task at hand. When an AI is asked about recent events or developments in a fast-moving field like technology or healthcare, it might provide outdated information if it hasn't been updated with the latest data. Another example is when an AI is used in customer support scenarios. It might offer incorrect advice if it hasn't been properly grounded in the company's latest policies and procedures. And these examples highlight the importance of grounding techniques to ensure AI reliability. So how do we cater for these challenges? Well, let's explore using multiple LLMs as a grounding technique. The idea here is to employ several language models simultaneously and cross-reference their outputs to improve accuracy. Multiple models generate responses to the same query, and their responses are then compared and analyzed to identify commonalities and discrepancies. The final output is synthesized from the most consistent and reliable parts of those responses. The benefits of this approach include increased accuracy and reduced risk of hallucinations, as the consensus among multiple models provides a more reliable answer. However, there are drawbacks such as increased computational costs and complexity in managing multiple models. For example, in customer service, using multiple large language models can ensure that the advice is accurate and consistent, as discrepancies can be flagged and reviewed before presenting the final response to the customer. Using multiple LLMs could also help in scenarios where a single model might struggle to provide a comprehensive answer. By leveraging the strengths of different models, organizations can create a more robust and versatile AI system. However, it's important to have a clear strategy for integrating and managing these models to avoid potential pitfalls such as conflicting outputs and increased operational complexity. Next up is human-in-the-loop grounding. Human-in-the-loop involves integrating human oversight into the AI's operation to validate and correct its outputs. The AI generates responses that are then reviewed by human experts who verify their accuracy and make necessary adjustments before approving that output for use. The benefits of human-in-the-loop include improved accuracy and reliability of AI outputs, as well as the ability to handle complex queries that require human judgment. However, the drawbacks include added time and resource requirements for human oversight. For For example, in medical diagnostics, human-in-the-loop can ensure that AI-generated diagnoses are accurate and reliable, with human doctors reviewing and confirming the AI suggestions. It's particularly valuable in high-stakes applications where cost of errors is significant. By combining the speed and efficiency of AI with the expertise and judgment of human professionals, organizations can achieve a balance between automation and accuracy. However, it's essential to design human-in-the-loop workflows that are efficient and scalable to avoid bottlenecks and ensure timely responses. Another effective method of grounding is using real data sources with retrieval augmented generation models, or RAG models. RAG models integrate external data sources into the AI's responses, ensuring the output is based on up-to-date and relevant information. The AI retrieves the information from real-time databases or APIs and uses this data to generate its responses. The benefits of this approach include increased accuracy and relevance of the AI outputs, as well as the ability to provide real-time information. However, drawbacks include the need for robust data integration and potential delays in response times due to the data retrieval. For example, in financial services, a RAG model could provide real-time stock prices and financial news, ensuring that information is always current and accurate. RAG models are particularly useful in dynamic environments where information changes rapidly. Organizations can ensure that AI systems provide the most accurate and relevant information by continuously updating the AI's knowledge base with real-time data. However, it's crucial to have reliable data retrieval and integration infrastructure to avoid potential data quality and latency issues. Incorporating contextual embeddings is another powerful technique for grounding LLMs. Embeddings capture the context of word and phrases from vast datasets, allowing a model to understand nuances and specific meanings based on context. Unlike traditional word embeddings, which provide a single static vector or numeric representation for each word regardless of its context, contextual embeddings generate different representations for a word depending on its surrounding words and the context in which it appears. This approach enhances the model's ability to produce contextually accurate and relevant responses, making it more effective in real-world applications. However, this requires extensive training on diverse datasets to capture a wide range of contexts effectively. For instance, training embeddings on industry-specific jargon and usage can significantly improve the accuracy of responses in specialized fields like finance or healthcare. Another good technique is fine-tuning the LLM with domain-specific data. This involves tailoring the LLM to specific domains by fine-tuning it with relevant high-quality datasets. The model is initially trained on a general corpus and then refined using domain-specific data to enhance its understanding and performance of that particular area. For example, taking, say, Gemini and fine-tuning on top of it. This approach improves the relevance and accuracy of the model's outputs for specific applications. However, fine-tuning requires access to substantial domain-specific data and it can be resource-intensive. A nice example here would be fine-tuning a model with medical journals and clinical trial data to create a more accurate medical question answering system, or building on top of an existing model so that you could use your tone of voice in creative outputs. And we can also use reinforcement learning from human feedback, and this is a technique where human evaluators provide feedback on the AI's outputs, which is then used to adjust and refine the model's parameters through reinforcement learning techniques. This method continuously improves the model's performance based on real-world feedback. The primary benefit of this learning technique is that it allows the model to learn and improve iteratively. However, it requires ongoing human involvement and it can be time-consuming. For example, using it to refine a customer service chatbot by collecting and incorporating feedback from customer interactions can significantly enhance its accuracy and effectiveness. Now, grounding techniques are essential for ensuring the reliability and accuracy of generative AI models. By integrating these techniques, organizations can improve the trustworthiness of their AI systems. Grounding is about anchoring AI responses in a solid foundation of truth, making sure they're not only coherent, but also factually correct.